All right, so I don't know how much work I'm going to get done on this today. I have another project. I have to build a tubing bender die for this thing, but to do 1-inch square tubing. So it looks like I can take all this pretty much apart again and we build a die and a follower. I think that's what you call this. That'll work with 1-inch square tubing. I'll show you the reason why later. But my current goal or my current plan, which is subject to change as always, I have this 1-inch thick solid steel plate that I've used to cut multiple basically shackle mounts for Jeeps. We welded onto our 1/4-inch bumpers, so you can put your shackle through it and use it for Jeeping. I was going to do like a 10-inch radius and make it go here, and that would be where you hold it. But I actually want to do a 180. My end goal has to be 12 inches tall, so that'd be a 10-inch diameter die with 1-inch piping. So your inside would be 10-inch, your outside would be 12. So that's my end goal. So it looks like it's going to be this inner marking with the center hole being here, and then multiple holes so you can adjust it as you're bending along the radius. So that's the goal, and then I'll put a 3/8-inch plate on top of it. That'll probably go either 1/2 inch or maybe 3/4 inch tall to keep the square tubing from bending out. So essentially, it'll be the 1-inch plate with 3/8 plate welded to the top, 3/8 plate welded to the top. This would be like a 1/2 inch tall here, and then the follower would essentially be the same thing. Oops, that's backwards. I guess it's not. Anyways, with a 1-inch block here, 3/8 on each side, so the full square tubing would sit inside that box as it's being bent along the radius. So I'll put the 1/2 inch plate on top, right? I'll drill a couple 1-inch wide holes so I can weld it inside, create plug welds that'll hold the 3/8 plate to this 1-inch block. So that's kind of the goal, if that makes all sense to you. I'll do probably the cutting with this with the plasma cutter, the 3/8 plate with the plasma cutter, and I'll do this 1-inch plate with the oxyacetylene torch. I'll probably drill this hole here and then put a stud through it and then bolt it through real nice and tight and toss this on the lathe to clean this whole diameter here. That way it'd be perfectly centered between here and here all the way around. Kind of don't like doing, well, I mean, I'll do it, but it always makes vibration because you'll have all this weight as it turns against this that has no weight. So your half circle will make my lathe kind of wobble and wibble. And that's mainly because it's sitting on a plywood deck in the container metal shed that I have. I use the Bridgeport Type 2 type lathe, or I'm sorry, mill, to drill these holes and whatever holes I decide around there. So that's the goal at the moment. I think what I have to do first is say hi to Cash. Hello, Cash. He's a good boy. Don't be a butthead. Here's a boy. Here's a good boy. Come on, let's go. So what I'm going to do is I'm going to take this apart, which all I really have to do is pull these pins. Yeah, 1, 2, and 3. And then it looks like I can do, that'll be my center hole that I was talking about. And then I can pick and choose which one of these to go with. But I think before I do that, I'm going to do this hole, machine the outside, weld the 3/8 plate to the big block, and then I want to put it in this machine and figure out which hole's going to give me the best leverage, and I need to figure out where my follower is going to sit, because it's got to be in one of these holes, and then it's got to be to where, just like this side, it's all nice and tight. So instead of it being a 1.5 inch diameter hole, it's going to be a 1 inch square hole. That way it follows through nicely. Then probably have to build something like this to hold, like this here is the 1.5. I don't know if you can read that. This is the 1.5 inch, I don't know, collar, whatever you want to call it. It holds the pipe. I'll have to build one that's 1 inch square tubing to grab it and hold it and bring it along. So it shouldn't be that difficult. It's just going to be meticulous testing, fitting. I know there's going to be a ton of people who be like, you leave this thing out. Oh, sorry, that was my hand, huh? I know there's going to be a ton of people out there that'd be like, oh, you leave this thing outside all the time. And yeah, I do, because it's bolted to the ground. I do live in the desert, so I don't get a whole lot of rain, but I also spray it all the time with white lithium grease. Well, that sucker's heavy. Right, there we go. All right. And up. Sandpaper away. That away. So, there we have it. I'm going to build something similar to that. The only thing I can say, I'm actually surprised that's only that thick. I was planning on having it be, close to 1/2 inch material. Apparently that's not 100% necessary if theirs is only like 3/8 of an inch. But mine will go, simply because I don't have that big of a whatever. Mine's going to be cut about there, right? So mine will be almost a straight out 1/2 moon. Well, this one is obviously, I don't know. I'll do math on that. This would be, well, from right here. Here would be 180. Oh, not quite 220. I don't know, whatever. But so this is where when I'm making continuous bends of the same shape, I mark it with my pencil, or usually my paint pen, or whatever you want to call them. I don't think I've ever, I know I've done a couple 180s. Rarely, but I know I've done them. But I don't do a whole lot past that, which would be putting it about there. I've never done anything really past 180, because if you did pass the 180, how do you get it out of that, right? Because it would basically lock itself in this once you get past that. So this will work. At least that's my hope. I had a tape measure yesterday. I don't know what I did with it. That's 2 inches. So 1 inch and 1 inch is going to be obviously, or 1 inch plus. Okay, so this is 1 inch, and then 2 3/8 plates, which is 375, right? 1 0 1 5 6 7. So it's going to be like 1.75 total thickness, which basically I'll just use like a 1/4 inch washer on the bottom of this to line it up center in that bender out there. Because all I have 1/4 inch, but 90% sure I have. No, that's not 3/8. That's 3/16. There. Okay. There's my 1/4 inch plate. I should be able to cut my little half wedges with that. I may not be able to, but I'm going to give that a shot. This is the only 1/4 inch I have? I think so. There's a dog. Well, let's go from there and see what happens. Well, I'm pretty sure everyone's heard the old, a plan never makes it through the first 5 minutes of engagement with the enemy. Plan 1 was to cut that big plate with the oxyacetylene torch. That plan is getting derailed because I can't find my cutting head. I have I don't know, number 2, number 1, I don't know what that is. I have that tip on it. I don't know where the cutting head is. So, once again, me being a slob has bit me in the ass. I keep all my strikers in one spot. I don't know where I would have put this. I have these. These are for bigger units. Way bigger units. I'm actually fairly certain that and that won't work with the tank I have. You need more pressure to make that work. I also have one back there that's for a machine. So, I honestly can't think of the last time I used this. We cut that plate 3 or 4 years ago to make those clevises for the 73 CJ5 with the 5.0 motor in it. So it's been a minute. I used the oxyacetylene gun or torch for brazing, for warming stuff up to bend. I don't generally use it for cutting because I have 2 different plasma cutters. I thought it would be in the horror freight box. I got a mixer, I got some hose, I got a big regulator. Well, shish kebab. I guess we'll work on this trying to find it first. I'll get back to you guys. Okay, so there's the cut section. Still very hot, but I wanted to get a 10-inch inside radius so I can have a total of 12 inches on outside. This section here is obviously missing a piece, but I'm going to fill that with weld and machine it all at one shot. And that's going to be my follow. That'll hold the other side of the box, square tubing. So with the 3/8 inch, with the 3/8 or 1/4 inch, that now that I see it, it would be here, and then this would be there. You'd have your 3/8 inch plate welded, or I guess it starts in 1/4 inch, welded to the top of this and to the bottom, so it sandwiches it. Same thing on this side, sandwiches it, and it should work out pretty well. I'm going to give that some time to cool and see how hot it is. That's still pretty damn hot. I don't know if you can hear that or not. You can see it. So I made this many months ago, at least 2012 to 14, some in that range, because it was at my house in Peach. Basically, flat bar, angle iron, set to sit right on top of this drum, so when you're cutting, all the slag and all the junk just falls right into the pit. It doesn't end up on your toes, doesn't end up hitting the ground and going underneath cabinets, so it works out pretty well. Usually use it for plasma, but obviously it works on this. Does look like it took some damage this time, but I can always cut those out and re-weld new flat iron in there. Haven't had to do it yet, and like I said, it's well, it's at least 10 years old minimum. So I'm gonna go ahead and put that cutter back where it belongs, put that back on the hose. Still kind of irritated, I don't know where the smaller one is, but I'm actually surprised that worked with these two smaller tanks. I did have to kick these on quite a bit higher. A little bit in the red, which probably shouldn't be. Go ahead and turn all this shit off. While I was this wrong way. While I was looking for the correct mixer, I did notice I have this steel here. It's long. That one might be a 1/2 inch. Let's have some 1 inch. Maybe 3/4. That might be 3/4. But I think I'll use one of these. That is definitely thicker. But I think I'll use these if they're big enough to make what I want. The same time I built that, I built this flat paneled thing that sits on top of the drums. It works out really well, same basic theory. It rotates, you can weld stuff, I can use it as a welding table. Yeah, I'm still not 100% sure where that other thing went, but whatever. So, in order to drill the holes, fairly sure I'm going to have to move this vise more in the center. I moved it over at one point because I was using that rotating table for a different project. Matter of fact, the hold downs are still here. I'll get rid of those, put everything back where it's supposed to be. clean this up and get ready to do what I got to do. But yeah, so we'll let that cool down for a bit because that is super hot. We will grind off all the edges, get it on the mill, drill out hole 1, which is going to be right around there. Sorry, right there. And I'm going to use a bolt to hold it firm so I can toss it on the lathe and true up the outside. And then I'll fill this section in with some just filler rod, probably with MIG welder. And then I'll finish cleaning up with the lathe. I'll probably use the mill and the cutting edge just to true up all that. And I'm not going to do nothing with this until I know where it's going to sit on that table. But stupid hot right now. So we're going to take a break while I clean up some of the garage. think this will be the last cut anyway. Yeah, I'm okay with that little piece not being all the way done. The next step is I'm going to drill a 1-inch hole right here, and then I'll find a way to tighten it on the lathe, and then we'll make the outside diameter true. Stop that. Stop this. And I'm okay with that. So we have trued up this side and this side, put a nice little radius in there. This needs a little bit of fine tuning, but the hole we want is going to be right there. That's where our center line is, and then we'll do 4 or 5 holes at a 4-inch, I guess it'd be 8-inch center, but it's going to be 4 inches away from the center of this one. So let's go ahead and drill the 1-inch hole, and then we'll put it on that. And actually, before I drill a 1-inch hole, I'm going to make certain I have a 1-inch bolt that'll go through it with a nut. My goal is to put a bolt through this with a nut at the backside, so it can hold as the shaft that'll go inside the lathe, so I can spin it and true the outside diameter or radius or whatever we want to call it. But we're making headway. In all honesty, we didn't have to do this, right? We could have used a grinder. For that matter, we could have left it all bare with the jagged edges. This will make it cleaner. We'll be able to measure off the straight edge here when we do, like when we calculate our bend radius. We'll have a good straight edge to go off of. There's reasons to do it. Is it 100% necessary? No, but this will be better. Alright, I do not have a 1-inch bolt. I do have this 7/8 shaft. So I'm going to drill a 7/8 hole in that other plate that's on the mill right now. I'm going to put this in there, extend it a little bit past the other side, and then I'm going to weld it to that other plate. That way I'll have a good solid connection with the shaft that's inside the lathe. I'll be able to spin that plate true and then grind off or lathe off the welds from the other side and drill it to 1 inch. That's the plan right now. So we're going to drill it to 7/8, toss this. I don't even know what the hell this is. Interesting though, it's got a stab with a threaded end. I cut it off at one point. So it'll go in that other hole, and then I'll drill it out to 1 inch after I get the outside trued up. So goal now, drill to 7/8. I like to start out with this type of drill bit. Make sure it doesn't wobble. Be able to put it right there in the center perfectly. And then I'll move up to maybe 3/8, ½ inch, all the way up to 7/8. So actually, with this lathe here, this mill, I can knock her down to about 120 RPM and probably cut from a 3/8 hole to a 7/8 in one shot. So we'll get started on that now. That's my starter hole. Okay, we are going straight to a ½ inch. I'm going to go ahead and put some oil in the hole. Start her up. Right now this is about 1,000 RPM. Knock it down to about 800 for a half inch. We'll see how that cuts. I'm sure you can see all the stuff spinning here. I am wearing safety glasses. Probably should have gloves on, but I do not. I'm also not going to reach in there and grab it. And we are broken through. So I put this on some half-inch aluminum bar I had, so I don't touch the table when I'm cutting or when I was milling the sides out. It's just a little protection. Yeah, these aren't going to be 100% perfect. These are going to have plus or minus probably 10 or more thousandths. But for what I'm building, this is going to be perfect. Yeah. Yep. So now we're going to grab a 7/8 drill bit out of my box of big ass drill bits, and we'll do that next. All right, 7/8 drill bit is on. I'll raise the table back up closer. So, if you were going to try to do this a little bit more accurate, you would lock that there. So it's all the way down, you lock it in, you'd pull this all the way up, which is taking forever, obviously. And you would measure, we know this guy's 1 inch tall, so you'd measure the distance. That's 7/8. That's about 1 inch tall, right? So now when you pull the quill down, it'll stop at 1 inch. It won't let me go and hit the table. But you can also feel when it breaks through. So is that totally necessary? No, it's not. But whatever. Just kind of showing you what you can do. Okay, I also forgot to say, this is 7/8. So 1,800 RPM, whatever it would have been way too high. So on a Bridgeport Type 2 clone like this is, you can put it in low gear. So that's low, forward is high, this is low. So now it'd be around 120 RPM, which is probably closer than, it's not on this sheet. But there's an actual sheet somewhere I have that tells me the optimum RPM range for different size bits. 7/8 is probably going to be closer to 140. So let's move it up to 140, which you're not supposed to move it while it's running. Oh, so now it's going to turn backwards, right? Now it's turning the correct way. We'll knock it up to 140. And we'll add a little bit of oil to the drill bit. This thing here comes out, and it goes in. Maybe a little faster. No, a little slower. So that's 120. Yeah, I'm okay with that. I'm gonna put down the phone so I can see what I'm doing. All right, what I ended up doing, that 7/8 wasn't cutting it, so I went with that one. But before I put that one in, I went with like a 20, oh, something else. Oh, it was probably 2732 or 2532. I don't know, just to get closer. And then I finished it off with that 7/8. You can see where I actually clipped the aluminum spacer, which is fine. But this is a really nice fit now. So it won't wibble wobble. I'll tack weld it in. What I'll do is I'll chamfer these on this side here so I can get a real nice weld. So I can toss it on that and not be afraid of it flopping around. What I might do, and I probably will do, is I'll put it in this, tighten her down, put the actual plate about 2 inches from this side. That way I can use a live center and make sure it doesn't wobble at all. So I got that drill there. Yeah, so that's what I'm gonna do. Let's do that real quick. I'll be right back. So now I have a center for that thing to ride in. And we'll put that plate somewhere around here, somewhere around there. So I guess I don't need it to stick out any, do I? Because this can, I don't know, we'll figure out how much hangover I do in a second. Maybe I'll right back to you. I may have mentioned earlier in this video lineup that unless everything's nice and true, this floor shakes pretty good. It's on 1/2-inch plate on both ends, but the base is steel plywood on whatever metal. Watch this. Yeah, there may be an issue here. I'm going to see if I can slow this thing down. If not, I'm maybe coming up with another way to chew this thing out. It's about there is okay. Need to find a smaller gear. So I'll work on that and get back to you. So this is going to take a bit of time, but at least it's not going to throw it at me. I'm going to try one other gear real quick. That's not bad. Alright, so we're going to bring this guy. Over to it. I'm going to turn this off real quick. I ended up not using the center rest because it's not deep enough. All these handles mixed with those handles, it's just not, I can't make it work without binding stuff. I think we're about 2, maybe 3 cuts away from being done. And then we'll get rid of the shaft, drill it out to 1 inch. And yeah, so I need to drill out the shaft to 1 inch, make my other 2 1/4-inch plates for each side of this plate so it'll hold the 1-inch round tube, square tube. Wasn't too far off for being hand cut with an oxyacetylene torch. It didn't like the carbide bit. See how I broke that carbide bit? I went with the straight stainless steel or tool steel with the rounded edge. That seems to be doing just fine. Add oil to it every once in a while. Just keep it cool. Yeah, it's like I said, 1, maybe 2 cuts more. I'm feeding super slow, so I have good control. I also tried to use not this one, this one. Tried to use that carbide bit too, and it broke it. I can resharpen that one. It's not a bit loss. But she's coming along. Alright, I'm gonna call that good, because I need to take a grinder to this section and build that up with some weld material. That I'm probably just gonna leave alone. That I know I'm leaving alone. These sides I'm gonna be fine with. I think I'll leave those alone. The only spot I definitely need to fill is this. Hang on 1 second. You can kind of see how much is missing. I knew that going into it, so that's not a big deal. But now it's time to take it over to the welder and fill her up. And then I'll bring it back here and I'll use the lathe to true that portion up. And then I might go a little deeper. I don't think I will. Well, I want to measure it because I need to make sure I'm hitting my mark. So for right now, I'm going to call this done. I'm going to go weld that up and measure everything and see how much further it needs to go. But so far, this is working out really well. I found the right speed, the right bit, and it is going well. So let's get to taking this thing off and go from there. Alright, you might be able to see where the weld was. So all this here, from about here to here, is all filler metal, about 1/4 inch thick. Came out really nice, all uniform. I went ahead and lathed off that just so I can lay this flat on the table and start making the secondary pieces, the plates that'll weld on either side of this, and stick up about 1/2 inch for the square tubing to sit in. So, and I'm thinking that 8-inch wide stuff shall work. Well, hell, we can do that right now. Oh yeah, that'll work just fine. If I put the 8-inch, God, I wish the 6-inch would work. Yeah, that's 6. That's 8. Well, why can't I use the 6-inch? I don't need to weld it to this bottom section. I could have it a 1/2 inch away from here. It'll stop a 1/2 inch away from here, but it'll still cover this entire section down here. For that matter, I can take, yeah, I'm going to use that 6-inch piece. Save that 8-inch for something else. I'll make it out of the 6-inch pieces. We'll have it a 1/2 inch away from that gap. Gonna make it a 1/2 inch extended. Then I'll just have to cut 2 corners out. 4, because 2 on each side. Yeah, I don't need to use that 8-inch and waste all that. I can use the 6-inch stuff. Alright, I'm tired. It's about time to eat lunch. Kill the mill and the lathe. And I think I'll go ahead and kill that fan in the back. And so I think I'm ready to go inside and eat lunch. But yeah, the 6-inch is what I'm going to use. Yeah, we still got work to do. Ain't no getting around that. Alright, I'll see you guys after lunch and when we start the other process. Alright, so we're using the soapstone to mark where we're going to cut it. I'll cut it on the outside of the white. That way I'll have my half inch for this to sit. Right? And then the other part, the follow, will have the other half inch. That way it'll hold this part perfectly. And you can be able to bend it. So, this is going to be the follower, which I will actually start working on after I get this thing completely finished. And then I'll make this part, which again I'll have to mill this nice and flat on all 4 sides. Once I got the hole, no, I won't do the hole yet. Once I got it built, I won't do the hole until I put it in the bender. That way, like this will be like that. It'll have a 1/4-inch plate going this way. That will have a quarter. Oh, I guess it'll be like this then. Hang on. Right? With a 1/4-inch of plate going over 1/2 inch each side. That way it completely encapsulates this side so it doesn't mushroom out or whatever, deform. Once I know where that is, this will be in the machine. This will have its holes here, and then I'll be able to mark where that hole needs to be to get that gap perfect for the 1-inch square tubing. Okay, so that's what we're going to do right now. We're going to cut 2 of those pieces out, then weld it to this piece I already built, and then get rid of that shaft. Actually, I'm going to leave the shaft in until I get these sides on, so I can spin it in the lathe again and machine these sides perfect. I may have to trim these down to get the plate in. Yeah, we'll work on that. Cool. Alright, I use a little mag drill here to drill this hole. I'm going to clean this little section up here with the grinder before I put it on the shaft on both sides and then start tack welding it. I also think I want to weld or cut a hole here somewhere else in order to do plug welds to attach it to this pretty much perfectly. So I'm going to find out where to put it. But the little mag drill worked out pretty well, so I'm happy with it. Now just a matter of finishing all this mess. To hold both plates together while I drill the holes, I tack welded it here, there, and there, so I can move it around and drill it where I want. I'm going to drill a hole about here. I'm probably going to drill 3 holes with this. Maybe not with this one. Maybe the smaller one. I'm just going to weld around the hole in order to connect it to this. It doesn't need to be all that stupid big. So let's get to that. Alright, what I did was I used this transfer punch, slid it through here. Well, this was on top of this, okay? So I lined it up with the one hole that I already drilled, slid this through, and I punched it everywhere that will be, right? Here, 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 there, and there, to match up the same 5 holes. And then what I did was I'm going to put a hole that I'm going to use to weld this plate to my base, or my center section, here, 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 and here. I wanted to make sure my plug welds didn't interfere with where I'm going to end up drilling. So this way here it should work out pretty well. But I didn't take a picture of that while I was doing it, but I basically just used this through the center hole in this. Let's see, is this still, it's off, okay. So I put it on top, lined it up, and then punched it where the holes will end up being. That way I can get these where they won't interfere with these holes. Hopefully that makes sense. I got 2 more plug weld holes to drill, and then we'll start welding this thing together. Plug welds are all done. Alright, so I fucked up. I was using the grinder without a guard as this thing was spinning in order to bring it to size. Kind of cheating, I guess, would be the best way to put it. But it got loose. Got my hand. Tore the skin up pretty good. I don't know if you can see that or not. But that was 5 or 6 stitches. Won't be doing that again. Obviously, I think the I don't know why I won't find neutral. There it goes. I think it grabbed it as it was spinning and maybe flipped it up like this, and I was holding it and it grabbed me like that. I don't know. Bad idea. Won't do that again.